You're welcome back. So today we want to evaluate the integral of log 2x plus 5 base e dx. Now you look at this integrand inside the integral very well. You see that it is a function of function. Now if you want to integrate function of function, you first use substitution method before you can think of other method that you are going to use. Now here you can now say that let t be equal to 2x plus 5. So having known the value of our t, the next thing is that we have to differentiate that t. So the t is equal to 2 the x. But here I need the value of the x. So I need to make the x the subject of the formula. So I have the x is equal to the t over 2. Having known this, the next thing is that I have to substitute all these values inside the integral. So I have the integral of log 2x plus 5 dx base e is equal to the integral of log, what is the value of 2x plus 5? T. So I'm going to put t. Then remember your base. What is the value of the x? The x is the t over 2. So I have 1 over 2 here, so I need to take it out because it is constant. So is equal to 1 over 2. Then integral of log t base e, then the t. Now you can see that this one is now in a simpler form. So I need to integrate log t base e dt. And to integrate log t base e dt, I need to use integration by parts. Why do I need integration by parts? If you see that I cannot use substitution method any longer, and I cannot integrate it by partial fraction, that is integration by partial fraction, I cannot use that. So the next thing is that I have to find a way of manipulating it to be in product form. And to do that, I will say 1 over 2 integral of log t base e, then you multiply it by 1, then you multiply it by dt. If you multiply any number or any expression by 1, as if you are not multiplying it by any number at all. Now, the next thing now is that for me to write the formula for my integration by parts. And the formula for integration by parts is an integral of u dv is equal to uv minus integral v du. The next thing is that which one am I going to take as my u and which one will be dv out of the log t base e multiplied by 1 dt. Now, what you have to do is that you have to use this beautiful acronym, which is LI8. L is for logarithm, I is for inverse, A algebraic, T trigonometry, and E is for exponential. Now, if you look at this expression here, the function inside the integral, I have log t base e multiplied by 1. The 1 there is constant, and there is no value of constant here. That means I'm going to take log t base e as my u. So it says u is equal to log t base e. The u, the t, is equal to 1 over t. So you can write it as the u is the same thing. The u is equal to 1 over t dt. That is, if you differentiate log t base e, you are going to get 1 over t. Now, the next thing is that I have to write my dv. So, and dv is equal to 1 dt. To find v, I'm going to integrate both sides of this equation. dv is equal to 1 dt. So, if I integrate dv, I will get v. If I integrate 1 dt, I will get t. So, having known this one, let's keep it, and we are going to substitute everything inside the formula for integration by parts. We have 1 over 2 integral of log t base e dt, which is equal to uv. U is log t base e, log t base e. Then v is t, so you multiply by t, minus integral v du. So minus integral v is t, then du is 1 over t dt. Now from here we can simplify this one. So t, we cancel the t at the denominator. So I have 1 over 2 integral of log t base e dt. But we should not forget that we have 1 over 2 outside. So let's put that 1 over 2 there. So is equal to 1 over 2, this 1 over 2, into bracket t, let it come here, log t base e, then minus integral of dt. So we have 1 over 2 into bracket t log t base e minus, if you integrate the t, you are going to get t. So t, close bracket, then don't forget your constant, which is c. The next thing here is that we have to recall the value of t and substitute it inside this equation. So recall that t is equal to 2x plus 5. So we need to substitute it there. The integral of log 2x plus 5, the x is now equal to 1 over 2 into brackets. Wherever we see t, we are going to put 2x plus 5. 2x plus 5 log t base e log 2x plus 5, then minus t, and t is 2x plus 5, so plus c. So we can now simplify this one. We can have 1 over 2 by expanding it, 2x plus 5 log 2x plus 5 base e, then minus, we can use this 1 over 2 to multiply this side as well. So we have 1 over 2 into bracket 2x plus 5, then plus c. So we have 1 over 2, 2x plus 5 log 2x plus 5 base e. Then let's expand minus 1 over 2 multiplied by 2x plus 5. So we have minus 2x over 2, then minus 5 over 2 plus c. So it gives 1 over 2 into bracket 2x plus 5 log 2x plus 5 base e minus 2 cancel 2 minus x, then minus 5 over 2 plus c. So this minus 5 over 2, it's also constant, so we can write the constant together, and we have 1 over 2 into bracket 2x plus 5 bracket log 2x plus 5 is e, then minus x, then plus c. So that is the integral of log 2x plus 5 base e dx is equal to 1 over 2 into bracket 2x plus 5 log 2x plus 5 base e minus x plus c. That is the final answer. So thank you. Bye bye.